Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 6 from the January 2023 Pure Mathematics P2 International A-Level exam from Edexcel. This question here is about circles. So it says the circle C has equation x squared plus y squared plus 8x minus 4y equals 0. So first of all, they're asking us to find the coordinates of the center of the circle and the exact radius of the circle. Now, the form of the equation of the circle, which is useful for us in finding these bits of information, is when it's written in the form x minus a squared plus y minus b squared equals r squared, where a, b is the center of the circle and r is the radius of the circle. So we can find the center and the radius if we rewrite this in the form, okay, where you have these brackets which are squared, which basically means we need to complete the square for the x and the y terms in this. So I'm going to take the x squared and the plus 8x and combine them, or write them next to each other, and the plus y squared and the minus 4y and write them together. And then I'm going to complete the square for x squared plus 8x. So I'm going to complete the square for this part here, x squared plus 8x. Now, to complete the square for this, what I'm going to do is I'm going to write this as we know how to do. We write a bracket which is squared. I'm going to put x, and whatever's over here, I'm going to write the sign plus, and the number that's here, I'll write half its coefficient. I'll write half the coefficient of this term here. So I'm going to put 4. I don't put the x with it, no, because when I expand this, I'm going to get x squared plus 8x. But then if I leave it like this, I'm going to get plus 16. I don't want plus 16. So I'm going to take away 16. This is the same exactly as x squared plus 8x. If I expand this, I'll get x squared plus 8x plus 16, then minus 16, x squared plus 8x. Similarly with the y, I'll do the same kind of thing. I'm going to put my bracket squared, I'll put y, and then I'll put minus half of the coefficient of this number, which is 2. But then I've got to take away, always take away the square of this number. So I'm going to take away the square of 4. Okay, and that gives me my answer there. So some people say, how come you take it away, even though this is plus and this is minus? Why are you taking away for both of them? Well, when I expand this, I'm going to get y squared minus 4y plus 4. Because minus 2 times minus 2 is plus 4. So I want to take away that plus 4. I don't want that plus 4 because we only have y squared minus 4y. So I have to take it away. So every time you always take away the square of this number inside the bracket, so you end up with what you are required to have. So now I can combine those two terms together, those constant terms together. So I have x plus 4 squared plus y minus 2 squared minus 20 equals 0. So now I can say x plus 4 squared plus y minus 2 squared equals 20. So I can say the center of the circle, so part 1, the center of the circle is basically the opposite of what's in here. Whatever x value makes this bracket 0, that's the x value, that's a minus 4. Whatever y value makes this bracket 0 is going to be the y coordinate of the center, so that's going to be positive 2. It's basically the opposite signs of what's inside the bracket. And part 2, the radius. Now the radius is equal to, we know that r squared is equal to 20. So therefore r is equal to the square root of 20. And it says exact, so I'm not going to round it, but I'll write it in simplified third form. So this square root of 20 is like, this is like the square root of 4 times 5, so it's going to be 2 times root 5. So there's my answer for the radius, and there's my answer for the center of the circle. There's part A done of question number 6. So you have to rewrite it in this form of equation of a circle from here to here, so that you end up being able to read from it directly the center and the radius. That's one of the advantages of having the equation of a circle written in this form. And now for part B. It says the point P lies on C. Given that the tangent to C at P has equation x plus 2y plus 10 equals 0, find the coordinates of P. So basically, we know that this line and this curve intersect, or they touch at P. Okay, so P is a point at which x plus 4 squared plus y minus 2 squared equals 20, and the line x plus 2y plus 10 equals 0. they intersect, or you can say they meet at P. Okay, they don't, it's a tangent. So basically the curve, you say there's a circle here, the tangent just touches the circle at the point P. It just touches it, right? So there's, like, you could say, a point of intersection at P. Okay, so basically, if we solve these two equations simultaneously, we should get like a repeated root. And that is, that will be basically the point. It will tell us the coordinates of the point P. So if I want to solve these two equations simultaneously, I will take the linear part and I will try to rearrange it to make either the x or the y the subject. Now, of course, it looks like the x is way easier to deal with. To make that the subject, you'll have x equals 10 minus 2y. And I can just use substitution now. Replace the x here with 10 minus 2y. I'll have an equation just in y. I can solve for y and then find what x is. Okay, so I'm going to replace the x with 10 minus 2y. So here I have 10 minus 2y and then plus 4 squared plus, and I've got here y minus 2 all squared equals 20. So I could do that. I could have even used the original equation actually as well. I could have used this as well. In fact, what would be easier? I think it would be easier to use the original equation, to be honest. Okay, so I'm going to do that. I think that's going to be easier to deal with because it's already like expanded. So it's x squared plus y squared plus 8x minus 4y. So you have x squared plus y squared plus 8x minus 4y equals 0. So what I'm going to do is I'm going to replace this x in these two places with 10 minus 2y. Okay, so I have 10 minus 2y squared plus y squared plus 8 times 10 minus 2y minus 4y equals 0. I don't know actually which is easier, but anyway, no problem. This is going to give me 100 minus 20 times 2 minus 40y plus 4y squared plus another y squared plus, this is 8 times 10, which is 80, minus 16y, and then minus 4y. Now I have an equation just with y's and y squareds in it. So I have 4y squared plus y squared, that's 5y squared. I have minus 40y minus 20y, which is minus 60y. And I have 100 plus 80, which is plus 180, and that's equal to 0. Now, I think 5 goes into each of these terms, so I have y squared minus 12y plus 5 into 18 goes 3 times, remainder 3, so plus 36 equals 0. Now, I'm pretty sure it has to be a perfect square because we have a repeated root here, so that coordinate is going to be, it's going to have two solutions basically, repeated answers. So here we can see this is a perfect square. This is y minus 6 times y minus 6 equals 0. So we can say y equals 6, a repeated root as we expected. So therefore x is going to be 10 minus 2 times 6. So x is going to be 10 minus 12. So x is going to be negative 2. Okay, so that's one way of solving this question. There are other ways, and I'm going to show you one right at the end, okay, which is another way of doing, which I'll show you later on. But anyway, there's part B, and so that's the point P. So we found the coordinates of the point P. Now we've got to find part C. It says, find the equation of the normal to C at P. Okay, so we have here, let me do this first. We have our center of the circle, we have our circle. Okay, we know that the tangent to the circle has equation as they told us, x plus 2y plus 10 equals 0. X plus 2y plus 10 equals 0. If you rearrange this, you end up with negative a half. So the gradient of the tangent is negative a half. So negative a half looks something like this. So let's say that the tangent goes like this. Let's say that this is the point P. Okay, if I rearrange this, as I said, I'll end up with 2y equals minus x minus 10. So y equals minus a half x minus 5. So the gradient of the tangent is equal to minus a half. Now the normal is a line which is perpendicular to the tangent and it goes through the center of the circle. Okay, so this is the center of the circle here. And the coordinates of the center of the circle, as we found in the first part of the question, is negative 4 and 2. That's negative 4 and 2. All right. So we need to find the equation of the normal. And we also know the point P is the point, as we just worked out. In part B, we worked out the coordinates of the point P are negative 2 and 6. Negative 2 and 6. Okay, so we are spoiled for choice here because we want to find the equation of the tangent. We can do one of two things. First of all, the equation of the normal, sorry. First of all, we need to understand that the normal is a straight line. And a straight line, we need two things to find its gradient. We need the gradient of the normal, and we need a point that lies on the normal. Now, we have 2 points that lie in the normal. Okay, so I could use minus 4, 2 or minus 2, 6. Okay, either of them. All right, let's use minus 4, 2. And the gradient of the normal, well, I could find the gradient by using these 2 points if I wanted to, but I know that the gradient of the normal is a negative reciprocal of the gradient of the tangent. The gradient of the normal multiplied by the gradient of the tangent must be negative 1. So that means the gradient of the normal is a negative reciprocal of the gradient of the tangent. So instead of being minus a half, you change the sign, becomes positive, turn it upside down, you end up with 2 over 1, which is 2. So that's now enough information for me to work out the equation of the normal. So you're going to use y minus y1 equals m times x minus x1. So you have y minus 2 equals 2 times an x minus minus 4, which is x plus 4. So we end up with, in what form do they want it? In the form y equals mx plus c. So y is equal to 2x plus 8 and plus 2. I'm just adding 2 to both sides as well. So y equals 2x plus 10. That is the equation of the normal to this curve. And that concludes, I think, the whole of this question. Yep, that's question number 6 done. Okay. All right, so that concludes this question here. Now, as for the other method of doing part B, okay, I'm going to go through that now as if we didn't do part C already, because another method of doing part B is like you got to do part C first, okay? And yeah, so that's what I'm going to show you how to do now. Okay, now for part B, it says the point P lies on the circle C. Given that the tangent to C has equation x plus 2y plus 10 equals 0, find the coordinates of P. Okay, so now, basically, the tangent to a circle, okay, let's have a quick think about that one. The tangent to a circle has the same gradient of that circle at that point, okay? So let's just imagine that there's a random, I'm just going to put P. Let's see, this is going to be 2y. That'll be y equals minus a half, isn't it? When you put it, so, okay. So we know that, let's just rearrange this. Let's take this equation first. X plus 2y plus 10 equals 0. So 2y equals minus x minus 10. So y equals minus a half x minus 5. So we can see that the tangent to C at B has a gradient. The gradient of the tangent is negative a half. Is the gradient of this tangent. Y equals mx plus c. So the gradient of this tangent is minus a half. Now minus a half is going to be something like this. Okay, so just say this is the tangent, right? So we know that this is the point P, and at the point P, we know that the gradient of the tangent, is minus a half. All right. Now we know that this is the center of the circle, and the center of the circle has coordinates, as we're told, negative 4, 2. Now, we want to find the coordinates of this point P. Okay, so what we can do here is the following. We can work out what the equation of this line is, which is the tangent to the circle. All right, we can work out what the equation of this line is, because how can we work that out? Because we know the gradient of this line, because this line, this is the normal to the tangent, will pass through the center of the circle. So we know that that this point lies on the normal, right? And we know that it's perpendicular to the tangent, so can work out what its gradient is, because when two lines are perpendicular, their gradients are negative reciprocals. All right, so this is the normal, and the gradient of the normal is going to be equal to 2, because it's a negative reciprocal. So we know that the normal, what do we know about the normal? We know everything we need to write down its equation. We know that its gradient, the gradient of the normal is 2, because the gradient of the tangent is minus a half, and they're negative reciprocals. And we also know that the normal passes through the point, the center of the circle, which is minus 4, 2. So we can say that y minus y1 equals m times x minus x1. So y minus 2, is equal to m, which is 2 times x minus 4, which is x plus 4. All right? So we end up now with the equation of this line as y minus 2 equals 2x plus 8. So we can say that y equals 2x plus 10. Okay, y equals 2x plus 10. That is the equation of the normal to this curve. All right. So now the point P is where the tangent, so you can say at P, the tangent meets the normal. Okay, so if we solve this pair of equations simultaneously, I have x plus 2y plus 10 equals 0. And here I can say 2x minus y plus 10 equals 0. 2x minus y plus 10 equals 0. Just like, putting them together. So we could solve this pair of equations by elimination. So for example, I could multiply the second one by 2. So this becomes 4x minus 2y plus 20 equals 0. So now when I add, so this is equation 1, I'll call this equation 3. When I add these two equations together, the y's will be eliminated. So I have 5x, 10 plus 20 is 30, 5x plus 30 equals 0, so 5x equals negative 30, so x equals negative 30 over 5, which is negative 6. So that's the x coordinate where they intersect. And then we know that y equals 2x plus 10. So we can replace that x into either of the two equations. This looks easier because we've got it set up like that. So that's 2 times negative 6 plus 10. So y is equal to minus 12 plus 10. So y is equal to negative 2. That means the coordinates of P are negative 6 and negative 2. Those are the coordinates of P. Okay, negative 6 and negative 2. All right, so that is part B done of this question. Okay, we found the coordinates of the point P. All right, so we had to find the equation of the tangent, which we were given. We had to use that to find the equation of the normal. Okay, the fact that the normal passes through the center helps us. And then we can find where those two lines intersect. And now, supposing we had used the method of part B that I just showed you, that would have meant we would have answered part C first, because to do it in that way, to find where the normal and the tangent intersect, we had to basically find the equation of the normal, and then we found where they intersect. We got the point B. That's perfectly fine. That would give you the answers to both parts of the question, but I would strongly advise you to write some steps here again in part C, okay, to show your, how you basically did it as well, just to be on the safe side. Don't just leave it blank, right? Either you mention answered in part B, or you should just show some main steps that you did in part B in part C again, just to make it clear that you've answered the question. But it is possible to answer part B by finding what part C is first and then using that to answer part B. That's perfectly fine. Okay, you might want to do part C first and then do part B, after that even. All right, no problem. But anyway, so that basically concludes this question number 6. Other questions from this particular paper, the January 2023 paper, can be found in the playlist, which the link will appear in this region over here. Other questions dealing with circles from P2, the link will appear over here. You can subscribe to my channel by clicking on the link in the middle here. And on the top, there will be a link to a video which will help you to navigate through my channel and find things that you need to find efficiently. Thank you for watching and see you soon.